Hello, good morning, dear children. I hope you are doing well with your studies. And today we are back with our physics class. So, of course, yesterday you must have enjoyed your class, and along with that, you are trying to complete your notes, right? So, because there is enough time for us right now, so you can do it by timely, right? Once your work becomes so much, so it will like pending only, so you need not to leave your work, you have to complete it by the time, so that you can enjoy your holidays, right? At the same time you can enjoy your classes. So with this hope, we will begin today with our next topic in this physics. Okay, so with a quick recapitulation, as you know, I will not move without that. So, in a last class, of course, we have gone through a very important types of systems of units. Okay, there we understood CGS, MKS, SI, and even FPS. But we got to know that SI, MKS, CGS are the metric systems. Means their multiples and submultiples can be expressed in the powers of 10. So thereby they are useful and internationally accepted, right? So I just want to explain you that some of the units which we have written along with their symbols last time, right? We have gone through such seven fundamental SI systems, SI units along with their symbols, like meter, which is denoted by M, and it is used for length, right? Similarly, kg, which is used for mass and written as kg, kilogram written as kg. And for time, we have seen it is second and written as in symbol as s. So the second is unit of time and written in symbol as s. So there are remaining with four also. We have understood for electric current, ampere, capital A, for temperature, Kelvin, capital K, for luminous intensity, candela, small c, small d, and amount of substance, mole, MOL symbol, right? Addition to that, yes, we have understood there are two supplementary units which are for plane angle and solid angle. So for plane angle, it is radian denoted as rad, RAD, and for steradian means solid angle, the steradian written as SR. So I'm sure you have understood this concept. Yes, by the time you have also took much interest and you have corrected me, so I'm very happy with that, right? So now I will explain you the basic definition of the first three units, and rest you are going to study by yourself in textbook already provided to us. Because while we have understood the categories or different commonly used system of units, we understood that these three physical quantities like length, mass, and time, right? Length, mass, time are commonly used there. So thereby, for length, I just like to introduce first the definition of length, which is very simple. We know that length is the distance of separation between 2 points in a space, right? So we are aware about the fact, but here the length we use generally meter. The meter is SI unit for length, and we try to define 1 meter. Here we will try to define first this 1 meter. So we know that what 1 meter is SI unit for length, and 1 meter is defined as the path traveled by the light in vacuum. The path traveled by the light in vacuum during the time interval of, pay attention here, during the time interval of 1 upon 299 792, comma 458. 1 meter is the path traveled by the light in vacuum during the time interval of 1 by 299, 792, 458 of a second. Of a second. Yes? And why it is important to learn? Because it might be asked, it could be asked in MCQ examination, though it is not in detail in our syllabus, but in various competitive examinations, you may go through such questions. Okay, so you can understood what is 1 meter. 1 meter simply the distance traveled by the light in vacuum during the time interval of 1 by 299,792,458 of a second. Got it? And of course, it is a SI unit for length. Next to that, we will try to define the physical quantity of mass with its unit, that is kilogram. So 1 kilogram. What is 1 kilogram? It is symbolically written as kg and meter is small m, of course. So no, we have to understood 1 kilogram. 1 kilogram or kilogram is the unit of mass. Of course, we are understood this concept well, but 1 kilogram is defined as, or it is actually the mass of a prototype cylinder which is made up of platinum, iridium, okay, platinum, iridium alloy. Okay, so 1 kilogram is the mass of prototype cylinder of platinum iridium alloy which has its height and diameter same. Okay, this cylinder has its diameter and height same, and this prototype cylinder is kept at International Bureau of Weights and Measurement at Paris. Okay, so this is actually 1 kilogram. And now next to that, we will define here 1 second. Okay, so of course it is a unit of time. Okay, now we will try to define 1 second. 1 second is defined as, or actually 1 second it is a period of 9, 192, 631, 770. Right? 1 second is a period of 9, 192, 631, 770. Period of radiation. Whose radiation? Period of radiation corresponding to the transition between two hyperfine lines of a ground state. Two hyperfine lines of a ground state of a 133 cesium atom. Okay, it is more important to understood. The question might be asked, right? How we measure the time? We are measuring the time vibration of 133 cesium atom, and how much that vibrations are. The period of vibration of the radiation is equivalent to 9, 192, 631, 770 times, which is corresponding to the transition of two hyperlines of a ground state of 133 cesium atom. Okay, so thereby we have to remember these three definitions. Other than that, all the rest are given in our copy. You just go through it. Otherwise, we have done with this three part here. Okay, and I think rest of the things are very easy, right? For an instance, the definition of mole, you are learning it yourself in chemistry, right? Means you have revised it again and again. The whole chapter was based on mole. So might you are aware about it. Done? And now next we have to understood the term which are for supplementary angles. What is supplementary angle? Because, supplementary units. So one is plane angle. In that case, we have learned in case of supplementary units, first we have gone through plane angle. Okay. And this plane angle is denoted as theta. So the definition of this plane angle is the ratio of length of the arc upon radius. Okay. Definition is what? The ratio of length of the arc upon, yes, radius. And its unit will be radian, written as RAD, rad. Okay. And second is solid angle, denoted as omega. Right? Yes, it is solid angle denoted as omega and defined as ratio of surface area upon radius square of the radius, right? And of course its SI unit will be steradian, written as SR. That is known to us and you are aware about that. We have gone through that in a last class, right? Yes. So here we understood this concept of plane angle and solid angle, right? And of course, why we have introduced with this concept? Because next to that we have to learn the measurement for length, and there we will use different methods where it is introduced in the terms of angle as well, right? How it is related? While we will start with the chapter points, you will understood that. For now, have you understood this? Is that okay to you? Okay, so now next, what is more important? You have to remember time is measured in case of 133 cesium atom, right? You have to remember this. Otherwise, plane angle and solid angle, you are learning it from 9th class. Though you know it, but you have to learn it today also, right? Now next, I will explain you some abbreviations in the power of tens, and they are seriously very much important, dears, because while we are using it in conversion for dimensional analysis, we even do not know the symbols which are written there, and we cannot write it in power of 10. So some of the commonly used abbreviation for power of 10 I will write on the board, and then if you need any extra, you can go through the books. Okay. So now next we will make a tabular form for abbreviations of power of tens. Pay attention here. If you learn it by clearing your concept, you need not to remember it. Okay. You can do it at the instant, at particular time, by using some formulae only, by clearing your terms only, right? So abbreviations in power of 10. So we will begin with first positive terms and their symbol, right? So first is deca, pronounced as deca, which is 10 to the power plus 1, represented as small d, small a, deca. Next is hecto, pronounced as hecto, 10 to the power plus 2, written as symbol small h. Okay, if there is small h, so you have to understood it is hecto, and in power of 10 it is 10 to the power 2. Next is, yes, kilo. And we are aware about this pretty much. Kilo, small k, 10 to the power plus 3. We are using it in daily life. Okay, but yeah, kitna kilo hai, right? Of course. So you are using it in terms of kilo. So we know that this. Next is mega, 10 to the power plus 6, written as capital N. Next is giga. Yes, this is, I'm sure you are knowing already this term. Giga, you are getting your data, network data in GB, right? Yes, 10 to the power plus 9. Yes. And denoted capital G. Then tera, 10 to the power 12. It is denoted by capital T. Next, peta, 10 to the power 15 plus 15, written as capital P. Can you see this? Okay, the last is here exa, 10 to the power 18, written as capital E. The last, I think, only for my terms, right? Because I have considered this many only, which are commonly used. Otherwise, you can go through this 10 to the power 4 as well, right? So first, we have gone through this positive terms. Now, the same thing can be written in terms of negative, but of course, their symbol and their meaning, okay, their name, both will be changed. So first we will say desi, desi, okay, it's like a fancy name, so you will easily going to learn it, right? Desi, 10 to the power minus 1, small d. Centi, 10 to the power minus 2, small c, right? Centimeter scale we are using, we know that 10 to the power minus 2, correct. Milli, yes, it is also a nice name, milli, 10 to the power minus 3, small m. Next, micro, 10 to the power minus 6, denoted as mu, Greek letter, mu. Okay. Next, here we have write 9, means nano, 10 to the power minus 9, nano for small n, right? Nano is also generally used, or even in our day-to-day life we have seen nano car. So do it means 10 to the power minus 9? No, it just take a general meaning of nano, that it is very small as compared to all the cars or the four-wheelers which are available till now, right? So thereby it is called to be nano car. It is not actually 10 to the power minus 9. It is small as compared to other four-wheelers or other cars, right? So thereby it is nano car. Next, pico, 10 to the power minus 12, denoted by P. Pico, 10 to the power minus 12. Next, femto, 10 to the power minus 15, and denoted by F, small f. Femtometer is generally used while we are representing the size of nucleus. Okay, so we have to learn it in 12th class, atom and nuclei. There you will use this term again and again. So it is femto, or generally when it is asked in terms of femto, you should write there 10 to the power minus 15. And lastly, otto, A-double-T-O, otto, 10 to the power minus 18, denoted by small a, right? So generally we are using this abbreviations in solving the numericals, or when we are going to relate the conversion with the help of dimensions. Okay, so you have to revise it and you will use it in dimensional analysis again and again, right? So this is all about abbreviation in power of tens. Have you understood it? Okay, so once we read it, what do you mean by micro? Yes, what do you mean by micro? Yes, you have to write beta. Ritika Giri, you have to write it in copy. You have to complete it. Yes, very good. The answers are listed here by the various students. I'm very happy to see. Yes, very good. 10 to the power minus 6. Edwin, Tejasvi, Bhumika, Tanmay, Sandhya, Kirti, Piyush, Priyan, Sharsha. Right? Yes, very good. Understood that. Auto, it will little, not that auto with which the three-wheeler we are moving, right? Auto. Auto is denoted by small a. 10 to the power minus 18. Very good. Adyan Sharma, very good. 10 to the power minus 18. Very good. And denoted by small a, right? So all this you have to revise again and again because it is somehow confusing there. How we can write it down? How we will get it in an example? Numericals, you have to, okay, why we have written this? Pay attention. When you are asked to calculate certain things in numerical, so you have to first see their system of units. If majority are given in CGS form, then you have to cover or convert the remaining into CGS. So you should know how milli is converted into centi or how kilo is converted to your gram, right? So according to that, we are going to use it. So first, suppose for an example, it is written as 1 mega ohm. The resistance is generally written as 1 ohm in terms of ohm. Resistance R in unit ohm. We are aware about this. We have learned it in 10th class. But if you have to write in its symbol, so it becomes 1 mega ohm, right? Mega is written as capital M. Ohm is written as inverse of that barrier, right? So it is ohm. And of course, when you have to write it in the abbreviation of 10, means it becomes 1 into 10 to the power of plus 6 ohm. It should be the factor to be known. So we can solve our numerical further, right? If it is provided to you, suppose 2 picofarad. Okay, 2 picofarad. Pico is, of course, the abbreviation of 10 and then farad. So what you will get? Yes, 2 pico for P, farad capital F means 2 into 10 to the power minus 12 farad. Farad is the unit of capacitance. Okay, so if you are not aware right now, no, I think you have done it in your 10th class. Though if you are not aware, then we have to learn it in 12th. Don't worry, right? For a while. Just understood how to you have convert this, right? Now, by using this term, we will solve the dimensional analysis. But before that, we have to gone through this basic points which I have written here on the board. You can see here the measurement of length first. Okay. So have you copied down? Shall we move ahead? Or you will do it later on? Okay, speak up. Okay. So should we start? Okay, good. Thank you. Now pay attention, the measurement of length. Okay. I have already told you there are 7 fundamental physical quantities, out of which 3 are again and again repeating because they are commonly used in everywhere. Otherwise, all the 7 are very important along with the supplementary units that is known to us, but these 3 are gonna repeat again and again. So we have to understood the measurement for length first. I have explained you the definition already. Length is actually the separation between two points in a space or distance of separation of 2 points in a space. That is nothing but your length. But they are certain types to measure this length. The first is direct method and another is indirect method, right? So we will start with first direct method. If we will be fortunate enough So you can come to school and you can do your practical by yourself as earlier students have done it, right? So there you can see by yourself how the direct methods are used. The one is you're very much aware that we are using our meter scale or centimeter scale with us, right? You have seen it from the first class pre-nursery, right? That you have meter scale and how it looks. It is a particularly transparent material, plastic material scale, straight scale, which is marked with 0 to 15 centimeter, right? And now we have to introduce with certain instruments which are even helpful to measure the length of or very small length of any apparatus, any material of any object, and it is named as first indirect method Vernier caliper. Meter scale is known to us. It is of course covered in direct method, right? Next one is Vernier caliper. Another is screw gauge and sperometer. Yes, I will show you it in next class how it looks, but how to use it, it is more important, right? In a scale, meter scale or centimeter scale, we are generally aware about only one scale. Means you just put your scale, mark 2 points from where you want to calculate the distance and draw a line, right? And you explain me that it is 2 centimeter, it is 0.5 centimeter, or even it is 0.1 centimeter. But what about that distances which are even small than 0.1? If they are even small in comparison to 0.1, then can be, yes, derived with the help of Vernier scale. This Vernier scale is useful because there are two scales. One is considered to be main scale and another is considered to be Vernier scale. Vernier scale is simply a line from 1 to 10, but your main scale is again exactly same as meter scale, centimeter scale, right? Centimeter scale, it starts from 0, then it is divided with the 5 digits and completed with the 15 centimeter, right? So this two separate terms will give us, means main scale reading and Vernier scale reading in gathering to this will provide us total reading, right? So we have to gone through all the concepts while we have to learn our practical or experimental session. So no need to worry right now. Okay. If you are not supposed to attend your classes, still I will show you in online class only. I will explain you how to use it. For a while, no need to worry. Just pay attention that it is a direct method called as Vernier scale. Similarly, there is another one, screw gauge, and there is sperometer, right? These are, along with the meter scale, are direct methods. But what we can use for far away objects like stars, like moon, like planets, so there are called to be indirect methods for measuring the distance or height of the objects which are far away from us, right? Which cannot be directly measured with the help of meter scale. If you want to measure the height of a tree or a tower on a road, are you going to consider a tape and going to measure it one by one, right? We can do that. If suppose you reached the electric pole, what happens? It should not be happen. So it should be, of course, we are aware about the fact that electricity should not flow there if you are trying to measure it. But more simple way that we even do not need to touch it and we can measure it, and thereby it is named as indirect method because we are not going to touch the object, right? We are going to measure it. Yes. So begin with the first indirect method for measuring the height of accessible object, for measuring the height of accessible object. Accessible means where you can not directly going to measure the point on that, but you are aware about the facts, means you can see it clearly, it is nearly close to us and you can distinguish between the bottom and top of that particular object. For an example, tree. If there is a tree on a road, we can say it is an accessible object. Okay, you can find the height of the tree or electric pole or a tower which is present on particular plane level of ground. Okay, so first we will begin with the triangular method for accessible object. This triangular method of accessible object is helpful to measure the height of tree, tower or any electrical pole which is on a plain ground surface, right? So we will start here first with the triangular method to measure height of accessible object. Okay, so triangular, of course the name suggests we have to consider certain triangle. Suppose we have considered a tower which is of certain height h. Okay, we have to calculate that actually, but if it is not known to us, we will represent it by s, height h, okay, or distance s. So we have considered, of course, with reference with the ground plane level, the tower having height AB which is equivalent to h, and next to that here AB is equivalent to h, the height of the tower. Next to that, what we have to do? We have to fix observation point from our side. This point C is nothing but a observation point for ourselves, and we will measure angle of elevation from this point C. How can we do that? How can we measure that angle of elevation? We have to measure this angle of elevation which is considered to be theta. We have to measure it. And this C is what? C is a point of observation, such that we have chosen that point of observation from base bottom of the tower as supposed to be x, distance x or s, whatever you want, right? But it is more important, this angle of elevation is measured with the help of secant. Secant is an instrument which consists of one eyepiece and two reflecting surfaces, with the help of which we can measure the angle of elevation between two visible objects. Okay, if the objects are far away, it's okay, but if they are visible, then we can measure the angle of elevation with respect to the two visible objects. So here is the peak of the exact top of the tower, and with respect to that, the point of observation, we have calculated this angle of elevation as theta. And you can see, we have already stated that it is on a level ground, means tower is perpendicular to the ground and right angle is at point B. So thereby in right angle triangle, what we will get? In right angle triangle ABC, of course, angle of elevation such that ACB is equivalent to theta. It is angle of elevation, but B is 90 degree, right? So thereby using the trigonometric function such as tan theta, what will be our trigonometric function? Tangent of angle of elevation tan theta. What does it say? It says it is a ratio of opposite side to the adjacent side. Means maybe you are commonly knowing it as the ratio of perpendicular to the base. The ratio of perpendicular is h, to the base is x, And if you are aware about the distance between B and C, the distance between the bottom of the tower and the observation point C, then you can find height of this object. Then you can find the height of the object. Okay? Have you got this? With the help of this, are you able to see this? Tan of theta. It is tan of theta. Okay, so here we understood this method. It is called as triangular method to measure the height of accessible object. We will try to solve numerical based on this. It is very important and should aware about it. More importantly, we are going to learn parallax method, but altogether it is beneficial for you to learn this. Okay, there will be no such restriction that you are not supposed to learn it. Once you know it, you can use it. Okay, so should we start with next one? Triangular method for inaccessible object? Yes, you are already there, right? Half of the knowledge is us. We have already considered how to find the height of accessible object, only exaggerating the things little more, because now the object is inaccessible. We will get the condition to be added and we will get our equation or mathematical form again for this inaccessible object. Okay, so I will just add a word here, inaccessible. Okay, and this is our second method. So now the same criteria we have to consider. We have considered inaccessible object. For an example, it should be mountain. Yes, we know that mountain is perpendicular with respect to ground, but its width will be much large. You cannot find out the width particularly of that mountain, and thereby it is considered to be inaccessible. Or if tree, but if I am talking about the shadow of the tree, then again it will be considered in particular inaccessible terms, because now you cannot able to measure the shadow for tower as well, right? So logically you have to understood which method you are going to use to solve this, right? So here, suppose you have taken inaccessible object AB which having height h. Likewise we have already done. So height is h, which is known to us. Now this time what we have done, we have to consider first observation point C as already is there, and with the help of secant only. The instrument secant is common here as well, right? With the help of which we will first measure the first angle of elevation, to measure the angle of elevation of the peak of the mountain, that is from A, top position. So at point C, you are going to measure the first angle of elevation as theta 1, right? And similarly, you are going to consider one more observation point named as D. Okay, we don't know the distance CB, and we understood it should be in terms of x only. But we have referred these two observation points ourselves. We know that first observation point is where, okay, and from that first observation point, the second observation point D is at a certain distance which is named as D, but we can calculate it. Means it is known term for us, whereas x is unknown, and of course h we have to calculate, right? Still we can solve it. Just you have to pay attention, because now with the help of secant we are going to draw and calculate again your angle theta 2, angle of elevation theta 2, right? And as we know that it also making an angle of 90, whether I will take the reference of D, right? In angle ABD, this is your considered angle of elevation theta 2, but at B it is 90 degree, right? So in first right angle triangle, which is your ABD. So angle of elevation is at D, which is equivalent to theta 2. So can you find the first trigonometric term as cot of theta 2? What will be cot? Cot is opposite to tan. And we have just write down the ratio of tan, opposite upon adjacent. So it will be inverted. Yes. So your tan can be written as adjacent upon height, means here perpendicular, right? Or we can say base upon perpendicular. So what will be your base in the case of triangle ABD? It will be the D plus X, not only D, it will be D plus X, means adjacent side or the base is D plus X and it is divided by the perpendicular H. This is our equation 1. Now we will calculate our equation number 2. So with the help of triangle ABC, in right angle triangle ABC, your angle C is angle of elevation theta 1. So you will get again the ratio, trigonometric ratio cot of theta 1 as x upon h. Okay. And this is our equation number 2. Right? So now what can we do further to find the height h? Now we can do that. We will going to subtract your equation 2 from equation 1. If equation 1 is subtracted from equation 2, what do we will get? Cot of theta 2 minus cot of theta 1. If left hand side is subtracted, so right hand side should be, means d plus x divided by h must be subtracted from x by h, as the base is common. So what we will get? H, d plus x minus x. So x will be cancelled out and you will get your height h, as height will be equivalent to what? This height will be considered as d upon cot of theta 2 minus cot of theta 1. This is the relation, mathematical relation for what? This is the mathematical relation to measure the height. Yes, to measure the height of inaccessible object, right? It is very important term to be understood and it will be used in numericals. So I was supposed to do one numerical also and complete the parallax method in this class only. But dear children, we are already running out of time. I think we have completed with 40 minutes. Okay. So I will not bore you much in this class as you have learned patiently. So thank you for learning patiently and responding me. I'm very happy. All teachers are very happy by the response of 11th class. There is no such competition that who gave the answer first, but we are happy that you are giving your answers. You are correcting, especially me, and I am happy with that class. Okay. So you just try to make a good points out of our class. So it will be healthy and enjoyable for us. Okay. So for today, it's all from my side. So thank you and goodbye. Take care.